Hello guys, in this video I want to take you through the process of trying to make this Alienware Aurora's R10 cooling system a bit better. This particular model came with an AIO on the CPU, so although the cooling performance of that AIO is not that bad, uh, it's really noisy because the original fan that it comes with is I think 3900 RPMs at max speed. And aside from that, the airflow inside the case is really bad. So that affects the CPU performance and the GPU performance. The GPU has two fans on it. It's a two-slot design on the cooler, and it does a fairly good job of cooling, but because of the bad airflow in the case, temperatures get really hot and it starts throttling under heavy loads. I saw temperatures on the GPU memory above 100 degrees. I'll try to show you some of the temperatures on screen before and after the mod, so you can see the improvement. So I purchased this PC back in November 2020, and usually I would build my own, but back then and even now, video cards were really hard to get at MSRP, and you either wait to get a video card or you pay scalper prices, which are really high, and it didn't really align with my budget. So I started to look for prices online, and at the moment I saw Thanksgiving sale from Alienware, and looking at the components that I'll put on screen, this actually ended up costing me about $100 more than if I would build it myself, considering that I would get a 3080 at MSRP, which was almost impossible at the moment. So I decided to pull the trigger on it, and like many of you out there, I got a pre-built instead of waiting for prices on GPUs to come down. More than a how-to, this is like a video blog, so you can see the problems I encountered and the solutions I came up with. And although I'm going full water cooling on this case, some of the things I'm going to be talking about may help you out if you just want to improve airflow inside the case and the cooling. So going through the specs real quick, we have the AMD Ryzen 7 3700X. It's an 8-core CPU with 16 threads. We have 16 gigabytes of dual channel DDR4 running at 29,033 megahertz. We have a GeForce RTX 3080 with 10 gigabytes of DDR6. The motherboard is a custom Alienware motherboard with a B550A chipset, which does support PCI Express 4.0, but only at 8 lanes. We have a 1 terabyte M.2 NVMe SSD and the killer Wi-Fi and Bluetooth card. It has, like I mentioned before, liquid cooling and 1000 watt power supply. This is the Dark Side of the Moon chassis. And with that out of the way, we can start disassembling the system. When it's brand new, this system comes with a screw on the back that holds the lock in place. You just pull on the lock and the side panel will come off real easy. As you can see, most of the space on the case is taken up by the power supply. You have to swing it out to see the inside of the case. It has two locks on the back, and as you can see on the video, I only removed the top one, so I was having a really hard time opening up the system. After that is just regular resistance to pull the power supply out of the way. Previously, I had already installed a fan on the top of the front of the case and replaced the one on the bottom for a couple of Cooler Master fans I had lying around. Those worked great with this motherboard and provided a little better airflow on the case and less noise than the stock ones. So here's everything I'm adding into the case: the fans, the GPU water blocks, the CPU water block, 2 radiators, and the pump. Considering the space we have inside this case, it's going to be a challenge. So to start, I removed the plastic panels from the case to make it a little bit easier to work on. You have to start with the top panel, and it's not screwed in or anything. You just need to pry it open. It does offer some resistance, so you have to be careful not to pull too hard and break it. Once the back of the panel releases, the rest come out real easy. And the back panel is very similar to the front panel, but doesn't have a lock, so you just have to pull it out. Similar, you start at the top, and once the top is done, the bottom comes out real easy. This was my first time opening up this case, and I didn't know that the chassis came with a solid backplate. This could be a problem because if you want to route cables through it or do anything on the bottom of the motherboard, you would have to remove it completely from the chassis. So the next step was removing the video card to see what we have to work with. It does come with a support bracket, which is great to avoid sagging. These video cards are really heavy compared to previous generations, so it is quite useful to have that. After that, you just need to remove the power cables. This particular model comes with 2 8-pin connectors. After that, you just press on the tab that holds the video card to the motherboard. No screws to remove. The video card is held in place by the power supply, so once it's released from the motherboard, you just pull it out. I didn't include the GPU water block installation in this video because it was too long as is, but it might post it later on as a different video. Once you remove the card, and with the PSU out of the way, it would appear that there's a lot of space inside the case. I've seen some videos where they just replace the thermal pads already on the card. The backplate does have a heat pipe, so it does provide some cooling. So if you don't want to go full water block on it, that would be an option. You still have to disassemble the video card completely, so that's probably one of the scariest parts of the build. The next step would be removing the AIO. You just need to remove the 4 screws on the top of the case. After that, you have 4 more screws inside the case that attach it to the motherboard. You have to remove the power cable for the pump and the fan, and also had to remove the auxiliary power cable to the motherboard so the AIO would fit, but it comes out real easy. So this provides decent cooling, but it's really noisy, so that's why I'm replacing it. So the radiators I'm going to be using are these Alpha Cool Nexus ST30s. They also have the ST45, which is 45 millimeter thickness. These are 30, and they are made for a 120 millimeter fan. I bought these in particular because they have several input and output ports depending on how you want to place them. They have two on the top, two on the bottom, and one on the back. So they're a bit more flexible as to placement. So once I tried to install the top radiator, it found that it's a bit wider than the original, maybe 1 or 2 millimeters only. I'll try to show you here. So that doesn't allow me to use the original mounting plate. I'll have to remove that and see what I can come up with to be able to hold them in place. So I removed the top radiator shroud, and it was fairly easy. Just need to remove 2 screws, one there and one on the back, and you just pull that out like you did with the AIO. This frees up a lot of space on the top, so the radiator now fits perfectly. It's just a matter to find a way to screw it in like the original. Something very important to mention is that if you plan on replacing your CPU cooler on this system, even though it's a Ryzen system, AMD processor, Alienware seems to use the same coolers for their Intel or AMD systems. So you will need an Intel bracket or CPU cooler to be able to fit it in. This is a Ryzen bracket that came with my CPU cooler, and as you can see, the holes don't line up. The Intel ones are on the outside. The EK water block I'm using includes AMD and Intel brackets, so that won't be a problem. My original plan was to place one of the radiators on the back of the case, but it doesn't seem to fit. You have that cable over there that goes into the front of the case with the power cable and the lighting, and if I flip it around, it won't allow the case to close correctly, especially because you have to consider that the hoses are going to be coming out of it with the fittings. So I'm going to move the drive cage from the front of the case to the back and see if it's a better fit over there. So I moved the drive cage, and there's a lot of more space back here. Doesn't seem to be any issues for clearance of the tubing. Just the SATA connectors may be in the way of the fan, so I'll probably have to move those to another place in the motherboard. And the only thing I don't like about this placement is that it will be in the way of the airflow on the fan on the front of the case. Getting back to the top of the case, to install the top radiator, I got these 2 L-shaped brackets. This will hold the weight of the radiator and will be sandwiched between the radiator on the bottom and the fan on the top. And also place this one on the back using the screw already in the case to hold the weight of the radiator so it won't sag to the back. So with a little movie magic, the top radiator and fan are installed. Like I mentioned before, I used the same screw that holds the fan to the radiator to sandwich the brackets in between. And I left this barb on the top as a fill port temporarily. Later on I might replace it with a cap like the other side. On the bottom of the case, I just installed the barbs on the radiator and put some electrical tape on the back bracket so it won't scratch up the radiator. and it also makes it disappear a bit because it's the same color. So I removed the plastic base from the chassis, and I just realized there's no holes in it. So any air coming into the case through the bottom intakes will actually come from the front of the case and not the bottom. So that's not really good. The other thing I realized is there's a lot of space here. I'm just gonna be drilling a couple of holes here so I can install the bottom radiator, but you could probably even fit the radiator inside the base or the fans. You just need to cut off a lot of plastic here, and obviously drill some holes for the tubing or the cables. To remove this, you just need to push those plastic tabs that it has 6 of them, and just be careful not to pull too hard because they're really easy to break.
So another neat thing about these AlphaCool radiators is they come with all the hardware needed to install them. They have 2 different long screws for the fans, short screws for the radiator, spare parts, the special tool to remove the caps on the radiator. Usually you use this type of cap that when you screw it in, leaves all this on the outside, but the ones that the AlphaCool comes with are flush, so it won't give you any clearance problems or anything.
Fast forward a bit, and the bottom radiator is installed, as well as the front fans. Now I need to install the water blocks. As I mentioned before, I'm not going to be showing the whole water block installation on the GPU. So I had to remove the motherboard. It's really straightforward, just 8 screws. Remove the cables and this little Wi-Fi card. The reason is because the backplate for the CPU cooler uses non-standard size screws, and the ones on my EK water block won't fit. So I had to remove it, which was really hard because it's glued on. And but you can heat the glue up with a heat gun a bit, and then just clean off the residue with some alcohol.
So this is the backplate that came with the CPU block. It's already installed. It has a gasket with it instead of the adhesive the original one came with. And now that the standoffs are installed, it's just a matter of installing the CPU block. I cleaned up the thermal compound on the processor, so used a little bit of alcohol to remove all residue. Before installing the new CPU block, I need to apply more thermal paste.
Fast forward again, I installed the GPU water block, but I had to remove the active backplate because even though it fits when you close the power supply, I was under the impression you could use any of the inlets and outlets, and it turns out you have to use one of the top inlets or outlets and one on the bottom, and there's no way to fit the tubing or the actual fittings on the top because of the PSU. So I had to remove it. Also, the active backplate's terminal gets in the way of this support bracket for the PSU, so that's something I didn't consider. Um, as with just the front part of the GPU block, it closes with no problems, and the connectors will go downwards, so there's no problem there. You could cut this, but you still have the problem of where to route the tubing to. So I had to reinstall the original backplate. The only downside to this is that it's a little bit longer than the water block, and this is where I was planning to route my tubing through, and now I won't be able to do so because it would hit the fans. The length of the card is almost exactly made for this case. The other detail is that I had to install the water pump on the outside of the case because there's no way to fit it inside. I just use more of those L-shaped brackets and some screws to fix it to the bottom plastic base. I could try to find a smaller water pump, but I had this D5 sitting there from a previous build, and I just bought the top for it so I can reuse it. The only thing is that I'll have to route the tubing to the outside of the case, but that's not such a big problem. So I installed the missing fittings and tubing to the system. Still need to add water. I installed the RGB controller and fan controller on the back. This motherboard does have RGB, but it's a custom RGB that only controls the ring in the front and the power button, and it's not compatible with ARGB or DRGB, so I can't use that with this fan controller. So the loop has water now and it's running. It was a little hard to fill it at first because it had a lot of air in it, and still you can see a lot of air bubbles running through the system. So I'll need to leave it a few hours or maybe a day so most of the air can get out. I'm running everything with an external power supply. It is recommended, if you use the installed power supply in your system, to unplug everything from it, just in case you sprung a leak. Nothing will short out, but I find it easier to just plug in an external power supply. I have this connector that came with a power supply I purchased earlier, but you can just short out pins 3 and 4 like I'm showing on screen right now, and the power supply will think it's connected to your motherboard, and you can use the power switch on the actual power supply to turn it on and off. So the system is up and running, but I have to run it like this for the last couple of days. One of the problems is that this motherboard requires that it has the fans connected directly to it, and because these fans have their own controller that controls RGB and the power, the motherboard wouldn't detect the fans and it would stop at post. The button to continue was grayed out, and I didn't find anything on the BIOS that would allow me to have it ignore the sensors for the fans. The BIOS on this system is very basic. It doesn't allow you to manipulate much of it, so that's why you have that tower of fans on the top. Is 4 fans that I had to connect. That's what another strange thing I found in this system is that originally it only came with 2 fans, and the third fan would be the water pump on the AIO. But when I tried to turn it on with 3 fans on those same positions, it wouldn't turn on. So I had to put a 4th fan in to get it to boot. I ordered some new fans. They will replace the RGB ones. and also an missing elbow fitting for the top radiator, because one of the hoses gets in the way of the power supply closing completely. So about a week has passed and the new fans are here. These are the Noctua NF P12 Redux. These are 1700 RPM fans, so they should be a bit quieter. And also got the elbow that I needed to be able to close the power supply. Too bad I have to replace the old fans. Those RGB fans were easy DIY fab fans that come with their own controller and everything on a kit. I have a review of those fans on a separate video if you want to check them out. I'll swap the fans and get back to you later on. So I installed the two front fans on the case. Basically had to disassemble everything because I will have to drain the loop to install the top fitting. And I removed this front cage that came with the case. It makes it really easy to install the fan on the bottom there, but it gets in the way of some of the air, so I just removed it. I installed the front fans using just zip ties to the case because it doesn't have any holes to put on the screws, and I didn't want to drill any more holes in it right now. It's much easier this way. So I'm mostly done installing the new fans. I installed that bottom one on the radiator. Also installed the elbow fitting missing from the top radiator so the PSU can close now. I rearranged the CPU block because I noticed some air bubbles were getting trapped on the top there because that was the inlet and the outlet was in the bottom. Now it's flipped over, so this will hopefully allow air bubbles to escape easier from the water block. I also went ahead and purchased this nylon tubing clamps because I noticed that this type of tubing is easy to pull off the barbs, and once the temperature goes up, the water pressure rises, and I don't want one of these tubes to just come undone accidentally. So I'm running the loop again with water to purge it of all the air bubbles again. You still can see a lot of bubbles running through the tubing, but I think that the tubing got a little cleaner this time around. The flow seems a little easier, and I also added this little display here to show me the water temps because I noticed the radiators and obviously the water temperature rising a little too much, so I need to monitor that. And some motherboards do have pins where you can plug in those sensors, but this particular motherboard doesn't, so I had to install that display. I'll keep it running for a few hours before trying to start the system, but no leaks so far, so it's looking good. So the system is now running. The temperatures did drop a lot on the CPU and GPU, especially on the GPU memory. I'll put some charts on screen so you can see the difference. The only problem is that I had to remove the top cover because with it on, the water temperature went up to about 60 degrees with heavy loads. Once I removed the cover, the temperature went down considerably. Still a bit hot, but much better. Right now it's sitting at around 40 degrees. That's about 10 degrees above room temperature. And with loads, heavy loads without the cover, it goes up to about 45 degrees. which is still a bit high for my taste. I need to think of a better solution for this, because right now you can't feel anything coming out of this vent or this one. Just when the power supply fan comes on, you feel a little heat here, but it's not anything major. The case right now has 3 intake fans and only 1 exhaust, so that's part of the problem. But I would have to cut out the plastic here on the top and then the metal on under the plastic to be able to put a fan there. I think that will be part 2 of this build. For now, I can use it as is, but I'm not really happy with the results as far as the having to leave the cover off. So I'll need to figure out a better solution for this, and the video is getting a little long, so I'll probably make a part 2 where I'll show you the finished build. So hope to see you here for part 2. Thank you for watching, and stay safe out there.